Okay.
Alison, maybe before we we continue, maybe it's better we you start again. So let's you start explain what the idea today, because as you know, the video was not showing, it's not displayed. So let me put here the camera, okay? So
Mm-hmm.
the idea for today is show how we can use stepper motor connected to our board, like you can see here in the screen, and this DRV 8080 2025 is connected to this uh, stepper motor, and the idea is to control it from NuttX side, correct?
Exactly.
Yeah. So to do that, you are creating um, a new board initialization, right? This
Mm-hmm.
STM32 DRV 8825.c, right? And
Right.
yeah, so maybe you can explain what you already did, and so why you are created now, how it's supposed to work now.
Okay. Okay. So yeah, as Alan says, uh, the, our goal today is basically try to implementate the this driver. So this driver is usually using for different application with step motor, and it's quite simple driver. You just need using GPIOs to control. So we need to select which pulses we we will use to select the direction, the deceleration, and others options. So let's start here. The first thing is to create, as I told, on boards, after that ARM, and move to STM32 commons, and finally we create a new file on source, uh, in source folder. Okay, so uh, usually we start create some functions, but before we move with that, it is nice to see how this step motor we really is implemented. So the first thing it is search for step, right? This here is the implementation. Uh, I guess it is this. Sorry, DRV 88. Um, here we have our implementation here. So we have some functions which it is important to use. So the DRV implements some setups, shutdown, work, and some I/O controls to control the acceleration and how many steps we will using. As you can see here, we have the idle function. We will implement that. We have the micro stepping. We need to implement that. Uh, some I/O controls. Yep. And the driver resistors that we use to register our driver. Okay. The first step, I guess, it is to uh, implementate our setup. So we move here, and I guess we're starting with STM32 GRV 8825 setup. Okay. So the first thing we need to find it include it is the some libraries like NuttX slash DRV, I guess. DRV. Can you help me, Alan?
Actually, you need to include
I
the
guess. Oh, okay. Motor
yeah, you need to include the stepper.
and here, and also we need to include to stepper, which is related to the motor, which is related to the type of motor and the driver. Okay. Also, we need to include some another header file. It is NuttX and config. Okay, and we need to include some others functions, but let's see the others implementation. So basically, we need to select the include the debug and the stdio. Okay, so sorry, here we need to include also NuttX arc and include, let me check the okay, I guess at first for first moment it is okay. Okay, so we need to search, we need to register our our drive. So the first thing it is create a return function, and then we can create int dev num and start to drv 8825 inits sorry register, and we need to register this we need to register this driver. So we need to select which is the path and DRV options, which is the our structure. So okay, so we need to select dev. Sorry, we need to put as print f. We create character program. So path. Okay, and we will put the path here and say dev stepper, and then which is dev num. Okay, okay, and after that we put our path here. Okay, okay, Alan, but
Yeah.
need to add it one more parameter here.
Uh,
It
Ha-
is
Also, I think the idea of create one by one is nice, but since we already tested it, maybe you have the example already done, so you can
okay.
just explain it because doing this way we it's nice, but
Spend
we spend all day
long time.
all
Yeah,
day doing
I
everything
agree with you.
from scratch.
Okay, actually, I tested before, so I speed up now. So okay, the first part is include this structure here. So basically, we need to make our initialization.
Hmm.
Okay, and just that. After that, we register here. Just let me finish this part, and then we can move to the next steps. Okay, so we need to implementation one more. We need to implementation these functions, which is initialize the stepper. The initialize basically we just configure the GPIOs to control the driver. After that, we need we develop the step function, which is the control the number of steps, the direction, clockwise or counterclock, and after that, micro steps, which is control if you want the one half, 1 part, and after that we have the enable function, which is enable the motor, and the idle function, which is just to stop the motor. So okay, let me show you what I did it. So the first thing it is to uh, initialize. So we need to uh, declare the pins here. We need to declare the pins. I guess you can help me.
Mhm.
We need to declare these pins.
You need to declare it inside the board. For it, actually, these pins are specific for each board, so they need to be declared inside board.h. Inside each board has an include director, and inside this include there is a board.h. So
Okay, so I need to
yeah,
search for our board and
yeah,
then
include include no, your
include. Okay,
yeah, board.h.
board.
Yeah,
Right. So let's put here. Okay, how you put here?
yeah.
So
Just put some comments about the stepper motor, like you did for for the for the other board include. Just
mm,
put it here. Um, yeah. I think we can. It could be in the other in the in the other header file as well, the board name dot h. But uh, I think Commons doesn't have access to it easily because Common is separated from our board, so
mm-hmm.
it need to be declared like here, for example. Yeah.
Okay. So I just okay. So declare here, uh, but I need to include the the architecture, but we need to include the board also too, also
Mm,
too.
I think it's Archboard. If you look, for example, um, in the user led or others other
Yeah,
files,
there's drivers.
probably you find it. But I think it for now you yeah
Yeah,
this
I guess we need to
Archboard
include.
board, yeah, this one.
Yeah.
Mm-hmm.
Okay. Uh, I just include those files here, and then we redirect for this guys. Okay. After initialize our pins, we need to edit another function like step. It is basically to turn off the step pin. Also, we need to include the direction, which is another pin to control the direction, which one. Okay. After that, we also include the micro step, which is to control how it is the resolution for the motor,
Mm-hmm.
which is the resolution for the motor.
I think we can return to the original numbers. For example,
Oh,
uh,
okay.
MS1, 2, and 3, and also the GPIO pins. We can change it to reflect
Mm-hmm.
the names.
Exactly. Yeah, just give more context about that. the driver itself creates those parameters like ms1, ms0, 1, and 2. But indeed, uh, our driver using another pin labels like ms1, ms2, and ms3. Okay, so here you
Uh,
also change
the
on,
GPIO, yeah,
yep, um,
1,
m1,
2, and 3.
3, but I need to change on initialization to
I change in 1, yeah,
2.
and here
Okay,
too.
so
Here too.
yeah,
In,
I did
in the
it.
micro step.
Uh-huh. Yeah, I see. Okay. So the next step is to include the idle function, which it is to turn on the sleep mode in the fall function, which it is just to return the 0.
hmm
And okay, for now, just that we implementing all those functions, but we need to declare the prototype those functions before the structure declarator, the deriv declarator. Okay, okay, I guess just that. Um okay, after that, we need to configure the makedef config, makedef file actually, and then we edit the configuration. So we have config and let me search because I forgot key here, and then um, we need to uh, select DRV 8825.
Yeah.
Okay.
Uh, Also, I suggest you to do the same to the CMake list as well to have it.
Mm-hmm. Yeah, we have two types for two ways to compilate our the NuttX, right? Okay. Mm, uh, let me see. No, here. I need to replace and put this configuration here, right?
Mhm.
Okay. Thanks for reminding.
Yeah.
Okay. And here, okay, okay. I guess for now it's just that we need to edit something on. Yeah, maybe it is important.
No,
I
you
don't
don't
think
need
it is
to. It's
it's
only if
important.
you want to, if you need to modify some specific thing, but this default
Hmm.
configuration is okay.
Okay, okay. It's for now. It seems okay. Let me uh let me open terminal here, and then we can.
Yeah.
Uh,
Now we need to
okay.
configure the board
Yeah. First, just
system.
clean. Okay. Tools. Um. Configuring. Message. and STM32F40. Can you help me? I forgot the
One RC
Earth
RS 485.
85 NSH USB.
No,
Why we okay?
USB and SH.
Oh, sorry. USB NSH. Okay, so we start using the USB and SH because we want to show you guys how exactly we configure this driver. I think it is important to see step by step. So let's configure our driver. Okay. After that, make menu conf. Open the make menu config. Great. The first thing, we go to the drivers and search for the step motor. So I guess found here step motor and select which step motor we will use and also select the step motor generic up half driver. Okay. After that, we exit again and move into the application. Go to the examples um, and let's see. Hold on, please. Okay, step motor test. Just that. X again, save, and then we can start to complete our part. Okay. Sorry.
Just a second.
Okay.
Opa! Bom trabalho. Maybe you include some incorrect in diff.
I don't think so.
Mhm.
Oh, yes, I put. Here, I found.
Yeah, and also
Yeah, we
something
need to.
you yeah, and
Uh,
something is still missing is the bring up initialization. Otherwise, this
oh
code
yeah,
this
you're
code will
right.
not be
I
called.
forgot. I need to go to
Actually, first you need to define this function inside the board common STM32 common, include and create some STM32 DRV 8825.h.
Mm-hmm. Yeah, I need to create this one. Okay, I forgot those steps. Those steps. Okay. Um, Let me see how exactly we implemented here. Okay, it is just board initialization. It is funny because okay, I should put boarding board initialization too. I guess something like that. Yeah.
Mm-hmm.
Okay.
Yeah.
Uh, let me see.
And now you need to remember the name. Okay. Yeah. I think it's correct.
Yeah, I just put some if defs here to make more, I guess, more, more interesting, you know. Uh, let me do the same thing here because I don't want to commit some mistakes during the compilation. Okay. Uh, okay. Okay. Just change the name here. DRV8825. Okay. I guess just that. And we actually it is include. And now we go to the bring up for our board. As you can see, STM32F401. So we search for STM32 bring up. Then we put here, we do the same part. And just change to our configuration, which is config step motor. Oh, sorry, here. Config step motor. I guess we don't need this now. We search for DRV 8825. Also, we need to include 25. Need to include here. Okay, is it important? Because our library will never found. So let me see. There are V here and if. Okay, I think it's just that for now. Right, Alan?
Yeah. Let's compile and let's see the errors and let's fix it.
Mm-hmm. Okay.
Still face some error in the make that. Did you save the? I think you forgot to save because
It's always saved actually.
uh,
I think it's
uh yeah, strange. Put some space after the if equals. And let's
yeah.
see.
What are you saying? Yeah. Okay. Yeah.
Yeah, that was that.
Okay. Let's see. Okay. This is
Yeah,
this
the
error
in the
we
application.
saw. I guess is here. We need to fix this error. Actually, we need to send a new PR for the main line. Um, step test, step test. Hold on, please. Um, here, step. We have this arrow here. Mm, okay, sorry. Uh, here, just need to. This is our edit. declarate, uh, and also um, we need to.
Yeah, I think that's correct.
Okay, I just put the other. Okay.
You don't need just pass the microstep 32 in the command line.
Okay.
Um,
Board initialization just not found.
yeah, I think you.
Uh, Let me search for the symbols. Yes, this is right, but was not found here. Strange.
Yeah, probably this file is not compiled.
Um, you mean the ST?
Yeah, this one. For some reason, probably is not compiled. You can just modify something here and type make to see if it's compiled. Yeah.
Type make.
Uh, V, uppercase V equal 1. Uppercase, no, V,
V.
uppercase V,
Uh,
no, 1 V, and it is uppercase. Uppercase V equal 1
equal one.
in uppercase.
Can you send me on the Jitsi?
No, just remove the this line in put uppercase V space uppercase
Uh-huh.
V uppercase the letter V in uppercase, not small v. Just V uppercase.
V RPG.
Yeah, the big V equal
Okay,
equal 1. Yeah.
like this.
Mm-hmm. Yeah. See, you modify the file, but it was seems like it was not compiled.
Mm,
There's some other some issues.
weird.
Yeah. See, I don't see the
Mm-hmm.
STM32 driver being compiled. Oh, I know. Maybe we forgot to select in the menu config that we are using common board.
Okay.
Yeah, common board not enabled by default. So just run make menu
Make
config
another
again
config.
and board selection. Select
Uh,
board common logic. Yeah.
okay. Let's see now. Okay, login for. Okay, it's just.
Yeah. Some include is missing.
Okay, let's see. You just include the 0.8 and include to include right, I guess.
Yeah, I don't remember about the syslog, but try that. Um, if it's not, I suggest you to look in bringup.c and other places that use the syslog.
Mm,
Yeah, try
no.
to make and let's see. If it's fail, you try again.
Mm, no, it's another word.
Enable. I think you forgot to create the
Ah, yeah.
enable function.
Enable function. Okay, yeah, you're right. Sorry about that.
No problem. Just copy this idle and create the enable from
Yep, yeah. Okay, I guess now it's right. Okay.
it. Good, very nice. Now
Yeah, really.
let's put the board.
Yeah,
Okay, you
yeah.
can see.
Actually, let's put on the turn off and um, go flash the firmware. Just wait. Um, reset. Yeah, yeah. And let's see. So, let's see. P. Sorry. Um, equal 1, 2, 3. Let's see. Uh, the
Verif
message.
yeah, verify if the stepper 0 was created.
Mm-hmm. It
Okay,
seems created. Register.
yeah.
Okay.
Now you need to run stepper, passing
The
stepper,
path.
dev step 0, uh, dash m32
Mm-hmm.
space, and the amount of
Steps.
steps you want, or step speed and the number. Okay, I think it's okay. Before you press enter, let's put the camera to see. Okay, let's see if the motor will spin.
Oh,
Okay, yeah,
okay.
we can
It's
see
running.
very slow. And now let's increase the pin, the steps, the step speed to 1000 maybe. And
Okay.
M32 uh, S
1,000.
no S, the S number, the speed per
Yes, sir.
second, dash S,
Oh, sorry. Dash S. Right. Dash S 1,000.
and 3000, for example, the number of you want to turn.
Up to 50,000.
Let's
Okay.
see.
And more.
Yeah, it's faster now.
Oh,
Yeah.
great.
Now if you type the same command but negative, it will run in the opposite direction.
Mm-hmm. Yes.
Let's see. Yeah.
Yeah.
Oh, very nice. Congratulations, Alison.
Yeah. Actually, I want thank you. It's thank you for helping. Thank you for support. And also thank you for the NuttX community. This is amazing driver. We can use in different application now. Uh, yeah, it's amazing driver.
Yeah,
It's quite simple but very versatile. It's
very
very
useful if you want to control some step motor. And it was a contribution from a guy from France, I suppose, Philippe Leduc.
mm-hmm.
And it's very nice. I contacted him a few days ago, and he give more information because this drive was missing this file that you created, and he supply an example, so it was very nice, and now we can submit it to mainline and help others to use it.
Yeah, definitely. And also, uh, I want to thank you, Felipe, too. Yeah,
Yeah,
he made some. I guess he made the sample for this app motor. And yep, I thank you for this community. Please still keep working and make incredible things. Yep,
nice.
for now. If you want, I test another thing.
I think for today is okay. We test this idea and confirm it's working.
Mm-hmm.
Um, so I think the next step now is clean up the drive and submit to mainline. And
Yep.
yeah, and let's see. And I hope it will be useful for more people. And as you said, let's see if people can start to play with it and use it for create some nice projects. Okay,
Mm-hmm.
thank you.
Oh, let me
Mhm.
let just show for the most of you know maybe, but Alan and I didn't show this part, so you just type step and then we have the path. We need to select the path, the micro steps, and the speed. So it just uh, we didn't show before we start to send the commands. You know,
Yeah,
just
the parameters you can.
the, yeah, it's parameters.
Yeah,
Yep. For now, we just did.
very nice. Okay,
I will play more. You know, with this. It's funny. You know, it's nice to see
yeah,
the motor
it's
the
spinning.
motor. Yeah.
Okay, thank you guys. I will close uh, the live now. Just a second.